So now we're going to talk about one-sided limits, this time from graphs. Obviously, we'll get to tables and the algebra and all that later, but some notation here. So a left-hand limit, I sometimes just shorthand left, or LHL for left-hand limit, just like right-hand limit. I'm going to put RHL. That's just something that I shorthand. Obviously, on the AP test, don't be writing that. That's not how they're going to accept it. You're going to have to write it with this notation here, write it out like that. But just so you know later on, if I put LHL or RHL, you'll know that I'm talking about left-hand limit, right-hand limit. And so what we use is an exponent. The negative exponent is the left-hand limit, and then the positive exponent would be the right-hand limit. And so what this means is from the left or from the right, not going to the right or going to the left. That would be a little bit mixed up. It's from the left. So if you want a left-hand limit, find 1 and go to the left of it and start there and approach 1. If you want a right-hand limit, start at 1, go to the right of it, and then come back to 1, approaching it from the right. So let's look at a couple examples. Really, really easy. If you look at this one, this is the limit, and I'm going to write it out because it's kind of hard to see in con. You might have to zoom in as well for your own sake whenever you do your con assignments, because I've seen plenty of mistakes here. Their pluses look like minuses sometimes. So this one's 2 from the left. So the limit is x approaches 2 from the left. So let's find 2. Here's when x is 2. So from the left, we are approaching 1. Look at the output there. The output is 1. From the right would be -4, but it's not asking from the right, so we don't worry about that. Let's look at this one. The limit is x approaches 6 from the right. I was going to put f of x, but this time it's h of x. So here's 6. So from the right of 6, so that's starting here from the right, we're approaching, let's look at the output at that one, is -5. So once again, I want to make sure you're clear. It doesn't matter what point is open or closed. See how this one's open and this one's closed? We're not looking for the closed point here. We're looking for what it's approaching from the right-hand side. See, like this one? It was approaching the open point from the left-hand side. So don't get mixed up by the open and closed point. That just means the function's defined right here. The function actually equals -4 here. But that's not what it's approaching. The limit, we only care about what it's approaching. Then one last one. Limit as x approaches 3 from the right. So as we approach 3 from the right, that's right here. So from the right, notice it's just going down. Con says unbounded. Sometimes you hear does not exist. For now, I think it's more appropriate to say unbounded, and that's what they're going to put in this con assignment because nothing's causing this function to stop. It just keeps on going down and down and down until we get to -infinity, so we say unbounded. There's no way to limit that function. So don't get that word limit mixed with the limits we're doing right now. Just think of this as that function is just going to continue to go down and down and down as we approach -3, so we'll say it's unbounded.